So in lesson 13, we are going to practice a little bit more with our balancing, identifying equation types. So this first one says to determine the oxidation states of the elements in the following compounds. So some of them are going to be easy. If they're ionic, then we're usually going to assign them the charge that the column they're in based on what we've already learned. Sodium's group 1A, has a 1 plus charge. Chloride is 7A, 1 minus charge. You could also do what we've done before, where you unswap the charges. So gadolinium, 3 plus, chloride, 1 minus. It gets a little bit more difficult when we start looking at things that have covalent compounds in them. So one of the things about the polyatomic ions is that they are groups and they are ions. However, they are covalent compounds that have an overall charge, and that's because of an unequal oxidation state in the elements between them. So lithium has a 1 plus charge. Nitrate has a 1 minus charge overall. However, the individual nitrogen and oxygen have their own oxidation states that we need to determine. And to do that, we're going to use a formula. So the overall charge on the nitrate group is 1 minus. But the charge of the nitrogen and the oxygen cannot be 1 minus. They have to equal 1 minus. So we have to apply some rules, which is in your reading. And one of the rules is that oxygen is going to want to be a 2 minus charge. That's one of the 5 or 6 rules that's in your book. And we have 3 of them, giving me a total of 6 minus for all of the oxygens. Now, nitrogen doesn't have a set rule, so we don't know what nitrogen is. We know it's going to be positive because it has to cancel out the negative of the oxygens. So we're going to rearrange it. Negative 2 times 3 is negative 6. So it's going to be x minus 6 equals negative 1. I'm going to add the 6 to both sides, which is going to give me a 5 plus charge for my nitrogen. So the oxidation state of my nitrogen is 5 plus and my oxygen is 2 minus. Okay. The next one is hydrogen and selenium. These are going to match their columns that they're in. Magnesium and silicon. The magnesium is going to be a 2 plus charge. And so in this case, the silicon is going to be our anion. It's going to have a 4 minus charge. So the reason why is because it has a least common denominator, a factor of 2. So the compound is not going to be magnesium 4 silicon 2. That's going to end up coming down to magnesium 2 silicon. Rubidium oxide, oxygen wants to have a 2 minus charge, which means the rubidium is going to have a 4 plus charge. I have 2 oxygens that have a 2 minus charge, giving me a 4 minus overall. To cancel that out, the rubidium has to have a 4 plus charge. Hydrofluoric acid, H plus, F minus, just like our first one we did with sodium and chloride. The next question here says to flip to the end of your chapter 4 and answer questions 14A through D. And so we're going to do 2 of them, and then I'll let you guys practice 2. So we have water plus solid carbon reacting to form carbon monoxide and hydrogen gas. So we're going to identify the type of reaction this is. So we have AB plus C makes BC plus A. So this looks like a single displacement or replacement reaction. The next one is going to be 2KClO3 solid forming 2KCl solid plus 3O2. So hopefully this is familiar to you. This is a decomposition, and we've seen this one on the previous lecture. when we were balancing equations. So you should have 2 more to practice and writing out the equations and identifying the type. We're going to do 2 of these acid-base reactions. The first one says a solution of HClO4 is going to react with a solution of lithium hydroxide. It is an example of AB plus CD, double displacement. But remember, one of the things it's always going to form in an acid-base reaction is water. So we have to identify where the water comes from. The water is going to come from the H plus and the OH, which is going to leave me with my salt, which in this case is going to be lithium and our perchlorate. So we have, pick a brighter color. There we go. Okay, coming together. So let's do the next one. Sulfuric acid plus NaOH. It's going to form water. In this case, it's actually going to form more than one water, but we'll get to that when we balance it. And my salt is going to be sodium sulfate. Remember, sulfate has a 2- charge, so it's going to put a subscript behind the sodium. So now if I go to balance it, I need 2 sodiums on the left. So I put a 2 in front of that, and I now have 1, 2, 3, 4 hydrogens. So I'm going to put a 2 in front of my water to balance the chemical equation. And so you'll practice this one. The last one here is going to be redox reactions. So in a redox reaction, we're always going to have a species that's oxidized and a species that's reduced. And we're going to have changes in oxidation states, and then we're going to have oxidizing and reducing agents to identify. So we'll do the first one, and then you guys can practice the last one. So looking at the oxidation state, magnesium is going to have a 0 because it's in its elemental state, and that's one of our rules. Same thing with nickel. The chloride is going to have a 1- charge on both sides, meaning that the nickel and the magnesium both are going to have a 2+ charge because there's 2 negatively charged chlorides, meaning nickel and magnesium both must be the positive charge. I'm going to break apart the equation into 2 halves, and it's going to be the magnesium breaking apart into magnesium 2+, and the nickel 2+ breaking apart into the nickel solid. And the reason why I'm doing that is because I need to see where the electrons are. So in this case, magnesium is becoming positive because it's losing 2 electrons. The nickel is becoming less positive because it's gaining 2 negative electrons. Now we need to think about our definitions. So the rule is oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So this is our oxidation because the magnesium is losing something negative while the nickel is gaining something negative. So oil rig. Another mnemonic you might know is Leo goes grr, which is loss of electrons is oxidation and gain of electrons is reduction, but they tell us the same things, which is great. So we've identified oxidize, reduce, changes in oxidation states. The nice thing about the oxidizing and reducing agents is they're the opposite. The oxidizing agent is the one that's undergoing reduction, and the reducing agent is the one that's undergoing oxidation. So in this case, my oxidizing agent is my nickel 2+. My magnesium solid, which is undergoing oxidation, is my reducing agent. So you're going to practice that with this next one right here, with the PCl3 plus Cl2 making PCl5. So this is a combination reaction. And the one we just did is a single displacement, single replacement, or also an oxidation equation, redox equation.